Good afternoon. Good afternoon. Hope all is well. Everyone's doing all right. Still have a few that's trying to connect, so we'll give them a few seconds and then we'll get started. All right. Looks like everybody's in that's coming in today. So last class, and always correct me if I'm not mistaken. Correct me if I'm wrong. Excuse me. We closed out. We did 7-1 and 7-2. And so today we're looking at 7-3 and 7-4. So we're starting off with best fit lines and prediction. Trying to see if my lab was coming up for me. All right. So best fit line, or in other words, the regression line, is a line that lies closer to the data points than any other possible line. And the next diagram is an example of that, but giving her a chance to write first. All right. So we talked about scatter plots last class. And this pink line within our scatter plot would be considered the best fit line or regression line. I'll just give you an example of how that looks. And go here because I had like 2 or 3 people that just came in. So this is where we are. We just got started. Best fit lines and prediction. All right. So scrolling up. So this section, neither 7-3 nor 7-4 really calls for a lot of calculation. Matter of fact, I'll show you how to we're going to do at least one of the problems out of 7-3, wherein you can pull up StatCrunch and it'll calculate it for you. But really, it's about the application. So here you see cautions of making predictions from best fit lines. The first one is don't expect the best fit line to give a good prediction unless the correlation is strong and there are many data points. Don't use the best fit line to make predictions beyond the bounds of the data points to which the line was fit. A best fit line based on past data is not necessarily valid now and might not result in valid predictions in the future. Don't make predictions about a population that is different from the population from which the sample data were drawn. And then remember that the best fit line is meaningless when there is no significant correlation or when the relationship is nonlinear. So I'll give you a chance to write those. All right, let's scroll up some. Trying to pull up this problem in MATLAB. For some reason, it won't come up for me. All right, are we done with the box? So for those who want to copy these down, I'll give you a chance to do so. It says state whether the prediction or implied prediction should be trusted in each of the following cases. Explain why not. So we're going to look at each one of these A through F and then decide whether it is a legit prediction or not and why not, if it's not allowed. So, and those situations will be based on what we talked about here, if it's not. There we go. All right, so let's look at the first one. You found a best fit line for a correlation between the number of hours per day that people exercise and the number of calories they consume each day. You've used this correlation to predict that a person who exercises 18 hours per day would consume 15,000 calories per day. So let's look at A first, and then let me see the best way to word this. Let's do it like this. I'll do a bullet time. Not be used, or should not be trusted. Okay, let's do that. Okay, so if you look at that first one, you found the best fit line for a correlation between the number of hours per day that people exercise and the number of calories they consume each day. You use this correlation to predict that a person who exercises 18 hours per day will consume 15,000 calories per day. So first thing is that no one exercises 18 hours a day, or not many people you would find that exercise 18 hours a day. So the prediction based on someone exercising 18 hours a day should not be trusted. So it's not a valid prediction because of the data that you're pulling from. All right. Looking at the next one, there's a well-known but weak correlation between SAT scores and college grades. You use this correlation to predict that the college grades of your best friend from her SAT scores. So the correlation. Let's say very weak or just weak. Okay, just weak. Correlation is weak. Now we're looking for strong correlations that would dictate that it's valid to use that as prediction to be able to predict. The correlation is weak. Mostly those two not be so few. Okay. Let me go like this, but not produce great accuracy. All right. So it says that the correlation is weak. So this means that the prediction would not produce great accuracy. All right, questions on A or B before we go C? So historical data have shown a strong negative correlation between national birth rates and affluence. That is, countries with greater affluence tend to have lower birth rates. These data predict a high birth rate in Russia. So historical. Move this down some. All right, so this is based on historical data, and we cannot automatically assume that historical data still applies today. And remember, all of this rationale comes from, I can erase all of these points right here. I can see, let's say, predictions. Okay, yeah, that's what I was saying. Data, past data is not necessarily valid now. Good prediction is based on strong correlation. So, you know, that one addresses the weak one. So these, all five of these address why something would be valid or why prediction would be valid or not be valid. So that's what we're pulling from. All right. So a study in China has discovered correlations that are useful in designing museum exhibits that Chinese children enjoy. A curator suggests using this information to design a new museum exhibit for Atlanta area children. Yep. Let's say you cannot. Let's say you should not. All right, so for this one, we should not assume the information about China will apply to people in Atlanta. Cultural differences should be considered and more research should be done before a prediction is made. All right. Question before E. Let me throw these down. Some. All right, so let's look at E. Scientific studies have shown a very strong correlation between children's ingestion of lead and mental retardation. Based on quote on this correlation, paints containing lead were banned. So What's the consequences? Yeah. All right. So for that one, because there is a strong correlation and the severity of the consequences are as they were, the prediction is reasonable. All right, last one like this. Says based on a large data set, you've made a scatter plot for salsa consumption versus years of education. The diagram shows no significant correlation, but you've drawn a best fit line anyway. The line predicts that someone who consumes a pint of salsa per week has at least 13 years of education. So here is a no correlation, right? But there. So because there is no correlation, so because there's no correlation, the prediction is meaningless. All right, questions before we go to the next thing? Mhm. Hold on, let me scroll this down. All right, so the next thing, I think is the last thing out of this section. Best fit lines, or in other words, R squared. So we have the square of the correlation coefficient, and our correlation coefficient is R. Is the proportion of variation in a variable that is accounted for by the best fit line. Also called It's also called the coefficient of determination. Well, y'all don't have to do that. You guys aren't dealing with the equation, so. So look at an example that helps us with the application of the coefficient of determination. Says you are the manager of a large department store. Over the years, you found a strong correlation between the store's September sales and the number of employees you'll need to hire for peak efficiency. During the holiday season, the correlation coefficient is 0.950. This year, the store's September sales are fairly strong. Should you start advertising for help based on best fit line? All right, so they give us R, the correlation coefficient. So if you square it, you get 0.9025, which is 90.25%. All right. So they gave us R. When we squared it, we got 90.25%, which is 90%. So this means that 90% of variation is accounted for by the linear relationship. And because 90% is so high, it is reasonable to use the best fit line to predict the number of employees needed for the holiday season. All right, let's scroll up. So one more thing out of this section would be number 6. That's just enough. All right, so I want to show you guys how to do this type of problem just by using what's in MATLAB. So this is 7.3, number 6. And it says we have a listed table below systolic blood pressure measurements obtained from the same woman. And they asked to complete parts A through D, excuse me. So we have right arm 107, 103, 99, 84, 83. Left arm 175, 169, 178, 146, and 144. All right. So first thing we can do is click on this right here. It says open in Stat Crunch. Hopefully, all right, we good to go. Let's see. All right, so Stat Crunch is MATLAB's version of like Excel. All right. So what we can do is, let's see, let's go stats and regression and do simple linear. So once again, go hit stats, regression, simple linear. And our X is right arm, Y is left arm. Those are the categories that we have. I can't move this so far. But the first category is our right arm, that's X. Second one is left arm, that's Y. Let's see. Don't need anything with hypothesis testing. I think that's all we do right now. Okay, compute. And so it gives us all the information that we need. Correlation coefficient is right here. R squared is right here. And then this is our scatter plot with the best fit line. So make sure you pay attention to how this looks in comparison to our 4 choices. There's only going to be one that matches what we have here. So notice we have all 4. We have 4 dots on the right side of our line and then 1 on the left side. So let's look at the one that matches that. And the 4 on the right are closer to the line. And this one on the left is a little further away. So let's see which one matches that. So our scale is a little different, but notice what we said. It was 4 on the right side of it, 1 on the left. So this one doesn't match. 4 on the right, 1 on the left. Hold on, continue. All right. This one doesn't match. This doesn't match as well. So the only one that comes close to matching is this one. So hope that is it. Okay, so there we go. So that's how you match it up, because the scale is going to be a little different. So you would looking at your best fit line, how many dots on the right side, how many on the left, and so on. So all right. So then it asks us what is R. So if you go back, hold on, can I have the wrong thing? Okay. Yeah. So if you go back, R is 0.93045. Let's see how many decimal places they want. They only want 2, so it's 0.93. All right. Then R squared, you go back. It should be this one right here. And I believe they only want 2 decimal places as well, so it's 0.87. So let's confirm. All right. Any questions so far? And then I just showed you that R squared is you convert that to a percentage, move your decimal 2 places to the right. So that should be the same thing, just 0.87 is 87% based on R squared. 87% of the variation can be accounted by the best fit line. So that's that. So identify any outliers. So let's look at our graph and see if any outliers. That doesn't seem far, but it is far in comparison to our dots. The other dots on the 4, because the other 4 are right up against the line. This one a little further away. So let's call it an outlier, see what happens. So that is 107, 175. Possible outlier is 107 to 175. The value is much higher than almost all the other values in the data set. Let's check. Nope. So it's not far enough away. So this one, which is a small data set, none of these points are likely outliers. So it was just a shot, just because. Let's go back to it. That was a little further away than the other 4. So I just took a shot. So, but it's not far enough away, so it's not an outlier. So that's why I chose D. All right. Does this best fit line appear to provide reasonably reliable predictions within the range of the given data? So based on predictions, it could not be, could not be, could not be. And it says the value of R squared is high. So the value of R squared is high, it's 87%. And the points appear to be somewhat close to the best fit line. So the best fit line appears to provide somewhat reliable predictions. So I will go with D. And there we go. All right. So questions on what we did there. All right. Assume that silence is great. All right. All right. So let's look at 7.4 real quick. Just these 2 boxes right here. All right. So the search for causality, guidelines for establishing causality. And so in this section, they're gonna present you with options, and you just analyze what you read and see if there's a reason for causality or not. So if you suspect that a particular variable is causing some effect, it says first look for situations in which the effect is correlated with the suspected cause, even while other factors vary. Two, among groups that differ only in the presence or absence of suspected cause, check that the effect is similarly present or absent. Number three, look for evidence that larger amounts of suspected cause produce larger or smaller amounts of the effect. Four, if the effect might be produced by other potential causes, make sure that the effect still remains after accounting for these other potential causes. Five, if possible, test the suspected cause with an experiment. If the experiment cannot be performed with humans for ethical reasons, consider doing the experiment with cell cultures or computer models. And then six, try to determine the physical mechanism by which the suspected cause produces the effect. All right, moving on. So when I was looking at the problems in Math Lab, they give you like 6 or 7 examples, and they say by the guidelines, determine if there's, causality or not. So, check those out, see if you have questions on it, see if you have any issues with establishing according to these 6 guidelines, and we can go from there. It's only 6 or 7 of them, so I don't want to take those examples away from you for trying it out. But if after you look at it and you still have questions, always feel free to bring them up during class. All right, can I scroll up on that first box? All right, and then we have broad levels of confidence and causality. So possible cause, we have discovered a correlation, but cannot yet determine whether the correlation implies causality. Probable cause, not cause, but cause. We have good reason to suspect that the correlation involves cause, perhaps because some of the guidelines for establishing causality are satisfied. And then cause beyond reasonable doubt. We have found a physical model that is so successful in explaining how one thing causes another that it seems unreasonable to doubt the causality. So you see in all 3 cases, they tell you how they relate to the legal system. It says possible cause is often the reason for starting an investigation. Probable cause is the standard for getting a judge to grant a warrant for search or wiretap, and then cause beyond a reasonable doubt. It says in the legal system, is the usual standard for convictions and generally demands the prosecution have shown how and why the suspect committed a crime. And it says, note that beyond reasonable doubt does not mean beyond all doubt. Questions on anything? As always, some questions may not show up until you actually have a chance to get in there. Was talking in the last class. Now, don't forget test chapter 5, 6 has been posted. We are looking to do 8.1, 8.2, and 8.3 at the most. So when we look at finishing out the class, those will be our last sections. Probably won't, no, I won't say probably, we will not have the opportunity to get beyond that. So we're looking at 8.1, 8.2, 8.3, try to close that out. And then from there, the final exam is going to be cumulative. It'll be on sections or chapters 1 through 8.
Wait, when is the exam again?
It'll be the week of the 5th.
December?
Mm-hmm.
Okay.
But I'm gonna give out dates, the actual dates soon. I haven't put them out yet. Yeah, I just know it's gonna be that week.
Okay.
And then since you mentioned it, what's gonna happen is I'm gonna give you multiple days to choose from. And whichever day you choose, you don't have to let me know, you just show up that day. And I'm gonna give you directions and everything as well. But yeah. All right. So questions, anything, anybody before we close out today? Everybody good? All right. So that's it for today. We close out chapter 7. Like I said, we'll get these last 3 sections and we should be good to go. And then from there, we just looking to get ready for the final. So you guys have a good one. Be safe, and I will see you on next class.